Okay, we got Dominique Foz. Okay, so let's give it another minute or so. Yeah, here's somebody. Ariana Sanchez. Okay, so here's the PowerPoint. We're going to talk about chemistry. So we're all made out of chemicals. We established that yesterday. So you have to know that protons are positive, neutrons are neutral, and electrons are negative. Electrons form a cloud around the nucleus, so there'll be questions on neutrons and so on. We got Johanna in. Okay, so back to chemistry. So know about these nuclear particles, and we'll move on. So the proton is part of the nucleus along with neutrons. Protons are positive and electrons are negative. The electron shell, electrons are arranged around the nucleus in like different compartments. The farther away the electron is from the atom is in the outer compartments. Okay, so you should know what atomic number means. The number of protons. Atomic mass is protons plus neutrons. Isotopes is when a atom such as carbon is carbon 12, carbon 13, carbon 14. So isotopes all have the same number of protons and electrons, but they have different numbers of neutrons. So carbon 12 is going to have 6 electrons and 6 protons. Carbon 14 is going to have 6 protons and 8 neutrons, but it's still carbon. Atomic weight, if you take all the various isotopes and you average that weight, that'll be what the atomic weight is of an element. So electrons surround the nucleus. They're organized in shells. The outer shell determines the properties of an atom. Okay, so you can see the carbon atom, as I said, carbon 12 has 6 protons, 6 neutrons, and 6 electrons. Neon has 10 protons, 10 neutrons, and 10 electrons. And the shells are, the closest shells are closest to the nucleus. So those electrons are really attracted to the nucleus. The outer shell electron is where chemical reactions take place. Okay, so we're made out of chemicals, and the foundation for physiology is how the chemicals in our body interact. So one type of chemical bond is an ionic bond. Atoms lose or gain electrons. So when an atom loses an electron, it becomes positive. When it gains an electron, it becomes negative. Cations have positive charge, anions have negative charge. And ions form bonds by the positive being attracted to the negative. So if you look at sodium chloride salt, you can see that sodium has 10 electrons, chlorine has 17. So sodium gives up 1 electron. Well, sodium has 11, 11. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 11. So sodium gives up an electron when it reacts with chlorine. Chlorine goes from 17 to 18. Sodium becomes positively charged. Chlorine becomes negatively charged. And the positive sodium is attracted to the negative chloride. So that's a basic ionic bond. NaCl is, of course, salt. So if you look at a sodium chloride crystal, it's arranged with alternating chloride and sodium. So when you dump salt from a salt shaker, which nobody should do anymore because we eat too much salt. So if anybody is in the habit of putting salt on your food before you eat, stop. Also, if you eat a lot of processed foods, TV dinners, and a bunch of junk from the store, it's all full of salt and sugar. Eat fresh fruits and vegetables and grains. Don't eat any meat. Don't eat any dairy products. Nobody's going to believe that, but that's the way to go. Okay. Okay, next slide. Where are we? I'm not going to save it. Okay, so you should know these symbols and these names. The most common ions in body fluid: sodium, potassium, calcium, magnesium, chloride, bicarbonate, biphosphate, and sulfate. So you should be able to recognize these ions, know their charges, and know their names. Covalent bond is another type of chemical bond where electrons are shared. And if they share electrons equally, they're a nonpolar covalent bond. If they share electrons unequally, they're a polar covalent bond. So what does that mean? So you look at hydrogen and oxygen. There's a single bond sharing of a pair of electrons. Oxygen shares two pairs, so each line represents a single covalent bond. Oxygen is joined by two pairs of electrons, two covalent bonds. Carbon dioxide has one carbon, shares two bonds with both oxygens, and the electrons are shared, but they are held more tightly by the oxygen. So this is a nonpolar covalent bond. This is polar because the oxygens tend to have negative charge because oxygen is negative when it shares electrons. So you should know that a single line represents a single bond with two electrons. Two lines represents two pairs of electrons or four electrons. This is called a double bond. This is called a double bond. You can also have triple bonds. As I just said, to review, non-polar covalent bonds, the electrons are shared equally. Non-equal electron sharing, the electrons are shared unequally. And we'll see that in water, oxygen is very electronegative, meaning that it will attract the electrons. So in water, the oxygens tend to be negative and the hydrogens tend to be slightly positive. We also have hydrogen bonds, which are incredibly weak attractive forces. Water forms all types of, one type of hydrogen bond between a polar bonded hydrogen and a polar bonded oxygen. So if you look at water, H2O, since the oxygen attracts the electrons and they spend most of their time moving around the nucleus, they spend most of their time around oxygen. So in water, we have oxygen tends to be slightly negative and hydrogen tends to be slightly positive. So this is polar bonds because the electrons are shared unequally. So you have a dashed line, that's a hydrogen bond. That's responsible for water's high boiling point, its ability to dissolve. So Water is a dipole because it has a slightly negative pole and a slightly positive pole, and these hydrogen bonds allow water to attract. It also is responsible for surface tension because at the surface of a water-air interface, the hydrogen bonds form a connected sheet, and that'll hold up insects and so on. So we just got to know about ions, and we'll get into chemical structures, and we'll show you the shortcuts. All you got to do in metabolism is all of your chemical reactions in your body, all the reactants consumed, all of the products, growing hair, growing fingernail, and so on. Do we have somebody trying to get in? Yep, we do. Okay. So just know that, well, we don't really need to know that working energy. Potential energy is stored energy. Kinetic energy is when that stored energy is used to cause movement. We're not going to worry about those. So we'll only talk about reversible reactions. That's what we're going to talk about. So the classic reversible reaction is bicarbonate. So when you breathe in CO2, it dissolves with water to form carbonic acid, and it dissociates, breaks up into bicarbonate and hydrogen ions. So go ahead and, as your little side assignment, look up the reaction of carbon dioxide with water and pay real close attention to that. Okay. When energy is exchanged, heat can be produced. Heat is wasted. It just keeps your body, well, it's not wasted because it keeps your body at 37 degrees centigrade. Okay, let's stop there. Let's get a short video. And we're going to stop recording. Stop recording. Stop.